Today I want to teach you guys a little bit of basic trigonometry, which is really just a complicated way of saying the study of ratios of sides in a triangle. So you can see that I have this triangle over here, and it's a right triangle. This angle right here has a degree measure of 90 degrees. Now, let's say that the base has a measurement of 4. And let's just say that it has a height of 3. And the hypotenuse is just 5. Now that I have the measurements of a triangle, let's move on to the trigonometry. So I'm going to be writing some functions over here. Sine. Now, these functions are as follows: sine, cosine, and tangent, or sin, sine, cos, cos, tan, tan for short. Now, really what they do is they specify for any angle in this triangle, it will show the ratio of certain sides. So I'm going to write something you can use to remember the definition of sine, cos, tan. So it goes, so, ka, toa. And this tool is something that really is essential in trigonometry and really is the basis of trigonometry. So this tool really, all this tool is saying is sine equals opposite over hypotenuse. Cosine equals cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Now, this probably does not make a lot of sense. You're probably thinking, what is he thinking about? Well, let's take an angle on this triangle and call it theta. So, let's call this angle theta. So we are asked to find the cosine of theta, the tangent of theta, and the sine of theta. So let's first start with the sine of theta. So, sine of theta. All we have to do is remember our nifty tool, SOHCAHTOA. Sine equals opposite over hypotenuse. So, opposite over hypotenuse. Let's first ask ourselves, what side is opposite of theta? Well, so let's draw an arrow directly opposite theta. Directly opposite. And we see that the side is 3. And if you notice, the side opposite of the angle is the side that the angle kind of opens on. So now that we know the opposite side, let's find the hypotenuse. That's pretty easy. We know that the hypotenuse is just 5 from the beginning. So the sine of theta is just going to equal 3 over 5, or 3/5. It's important to remember that the sine of this angle right here is always going to be 3/5, because the ratio from the opposite to the hypotenuse is always going to be the same, even if it was a larger triangle. So now let's find the cosine of theta. Cosine of theta. Cosine theta. The cosine, looking back at our mnemonic, is just adjacent over hypotenuse. Adjacent over hypotenuse. So, finding the adjacent side, let's find the adjacent side. It's the side that kind of makes up the angle, and it can't be the hypotenuse. Well, the only side that fits those requirements is 4 right here. So the adjacent side is going to equal 4. And once again, we need to find the hypotenuse. And we know that the 5 is hypotenuse. Let me label 5 as hypotenuse. So the cosine is just going to equal 4 over 5. Now, we need to find the tangent of theta. Tangent of theta. Looking again back at our mnemonic, we know that tangent is opposite over adjacent. Opposite over adjacent. So, again, we know that the opposite side is 3. Opposite is 3. So, tangent is just going to equal 3 over, let's see, adjacent. And we know that the adjacent side is 4. So, tangent is just going to equal 3 over 4. So knowing all the sides in the triangle, we could just figure out the 3 big trigonometric ratios in the triangle. It is important to remember that these ratios only apply to that angle in the triangle. These ratios are not the same value of, let's say, this angle right here, angle X. This angle X, is not going to be the same as angle theta. The ratios are not going to be the same value. Furthermore, our tool that we have here, our SOHCAHTOA tool, will start to mess up at angles greater than 90 degrees or 90 degrees, and it only works for angles less than 90 degrees. So in future videos, we'll create a new formula that will work for any angle. But for now, just remember SOHCAHTOA.